In this video, I'm just going to introduce and kind of compare how to do a U substitution whenever you have limits of integration. One example I'll do side by side and see how they are kind of similar and kind of different, maybe a little more efficient. So I go ahead and approach both of these the exact same way. I'm going to do a U sub. I have to let U equal the inside part, which in this case is rather easier to see. It's 2x plus 1. The derivative of that, it's du. Dx is going to be 2, cross multiply. Du is going to be 2 dx. So the inside part is going to be what I let u equal, and this extra dx is what I have over here. I don't have this extra constant of 2, so I divide it over. So it's 1/2 du is equal to dx. So now my integral turns out to be u to the 1/2 power dx gets replaced with 1/2 du. Go ahead and factor out this constant 1/2 u to the 1/2 du. I go ahead and apply the power rule on this, which gives me 1/2 u to the 1/2 antiderivative of that. If I add the power by 1, it's 3 over 2, all over 3 over 2. I go ahead and flip this, so it's going to be 1 over 2 times 2 over 3 u to the 3 over 2. I go ahead and reduce this. I have a 2 and a 2, so basically what I have is 1 over 3 to the 3 over 2. Now, it's a integral back in terms of x. I'm going to put this as 2x plus 1, and then go back to my initial limits. Go back to my 0 and my 4. So it's 0 and then 4. So if I go back to my initial limits of 0 and 4, I have to go back in terms of x. So this now becomes 1 over 3. Upper limit's going to be 4 plus 1 to the 3 over 2 minus 1 over 3. My lower limit's going to be 0, so it's going to be a 2 times 0 plus 1, all raised to the 3 over 2. So all I did in this step was evaluate my top limit and then substitute in my lower limit, and now I'm just simplifying. So this now becomes 1 over 3. The inside is going to be 2 times 2 times 4 plus 1, which is 9, to the 3 over 2 minus 1 over 3. This is 1 to the 3 over 2. This over here is the square root of 9 to the third power. So square root of 9, which is 3, third is 27. This is 27 over 3 minus 1 over 3. So my answer is 26 over 3. So that's what my answer is over here on the left. Now, if I work out the exact same problem, I have to start the exact same way. U is equal to 2x plus 1. Du is going to be a 2 dx divided by 1/2 over. So the integral doesn't change. I still have to do the u to the 1/2. I still have this 1/2 du. I still have to factor this out. I still have to do the power rule. So up until this point, it's the exact same process. So 3 over 2. I reciprocate this 2 over 3. I go ahead and change this or simplify this. So basically, I have 1 over 3 u to the 3 over 2. So up until this point, it's the exact same problem. Only difference is now, instead of going back to 2x plus 1, I'm going to change my limits by plugging in 0 at this point. So 0 plugged into this, 2 times 0 plus 1. This is basically u of 0. Gives me 1. That's now going to be my new lower limit, which is 1. If I plug in u of 4, so I'm plugging in 4 into what I let u equal, that's going to be 9 So that's going to be my new upper limit. So really what I have to simplify is 1 over 3 u to the 3 over 2, going from 1 to 9. So if I change my limits, I stay in terms of u. I don't go back to what x is equal to. Because now when I evaluate this, it's going to be 9 to the 3 over 2 minus 1 over 3. And so this simplifies to the square root of 9 to the third power is 27 over 3 minus 1 over 3, which is 26 over 3. So I'm kind of doing this step. I'm doing all of this in this part of it. So I'm kind of condensing the problem just by changing my limits. I don't have to go back in terms of what x is. I can just keep it in terms of u and keeps the problem a little more condensed, a little neater, so you don't have to write as much or maybe necessarily do as many calculations, where it's a little bit neater to work with. And that's a comparison. You'll get the exact same answer.